So what we're going to start with is just the sine graph. We've already taken some pretty extensive notes on that sine graph, but the original has a midline of 0. You start at 0, 0. At pi over 2, you are up 1, so I'll label those. At pi, you are back to your midline. At 3 pi over 2, you are back down. And then at 2 pi, you're back at your midline. So that is your standard parent graph. That is y equals the sine of x. Parentheses do matter on this, just an FYI. I'll show you why in just a little while. So, the general equation is y equals a. I don't want parentheses there yet, sorry. Sine b parentheses x minus h plus k. And then I'm going to put an extra set of parentheses here. Again, I'll show you why later. So, A changes your amplitude. More specifically, A just tells you your amplitude. As we've discussed before, the amplitude is the distance from the midline to the highest and lowest point. So the standard parent graph has a midline of 0 and an amplitude of 1 because you go up to 1 and go down to negative 1. A simply tells you your amplitude, distance from the midline. B is the new one. We'll talk about that in a minute. H moves you left or right. And K moves you up or down. Specific to sine and cosine graphs, K tells you where your new midline is. So B, the new parameter we haven't dealt with, is what's called our frequency. The frequency tells us how many cycles we are going to complete within 2 pi. Our standard sine graph, as well as our standard cosine graph, completes one full cycle, that midline up, midline down, midline. It finishes one cycle within 2 pi, so it has a frequency of 1. If, however, we change that to, for example, y equals sine of 2x, that means that we are going to complete 2 cycles within 2 pi. So, with a normal sine graph, I am going to start here, and I'm going to finish here, and I'm going to complete 1 cycle within 2 pi. If I have to complete 2 cycles within 2 pi, when do I have to finish 1 full cycle? By pi. I have to cut that in half. So I have to change that so my start is here, and then my end is here. And I still need to look at that same, back down, start, go up, midline, down, midline. So I'm still going to do that, it's just going to be condensed now. So where's my middle point going to be? Close. I think you're just thinking I was referring to something else. So my middle point, like if I'm looking at these 3 points here, those 3 points on my midline are now going to be squished in half. And so at pi over 4, I'm going to be up to 1, and at 3 pi, or sorry, that would be 3 pi over 4, I'm going to be down to negative 1. And if I were to continue this, and I'm going to do so in a dashed line, because I only want one cycle drawn here, I would be completing 2 cycles within 1 pi, or within 2 pi, sorry. So this right here is 1 cycle, which makes my period length equal pi. So something like that is a little bit more difficult because the frequency is 1/2, which means how many cycles am I finishing within 2 pi? Only a half of one. So how long is it going to take for me to finish a full cycle? 4 pi. If I look back up at the top, my full cycle is 2 pi. This is for the standard one. My period length is 2 pi. When I moved down to a frequency of 2, I finished that one cycle, that up, down, up, within 1 pi, and I got 2 full cycles done within 2 pi. When I look at something like 1/2 x, that changes so that I'm only getting 1/2 a cycle, so just this top part within 2 pi. So between my starting point and 2 pi, I am only getting this part done. So to get a full cycle done, that's that 1/2 the cycle. To get a full cycle done, I have to go clear out to 4 pi. So my frequency is 1/2, but the period length is now what? How long does it take to complete one full cycle? 4 pi.